Welcome to Physics, Chapter 7, Law of Universal Gravitation. This is the updated schedule. You'll notice that the review days are next Tuesday and next Wednesday. We do not have class on Friday, so the Chapter 7 test will be on March 2nd for Physics B and March 3rd for Physics A. Lesson outline. You will be asked answer any questions, and then it will be followed by a quiz. We'll have some quick notes on the Law of Universal Gravitation, and then there will be a Law of Universal Gravitation worksheet that we'll work on in class. Homework is review Chapter 7, review Chapter 7 practice problems, and study for the test. Learning targets. I can explain Newton's law of universal gravitation and apply Newton's law of universal calculation to calculate the gravitational force between two masses. Newton was born in 1668 in England, 45 years after Kepler, and is best known for the apple falling and realizing that there is a force that pulls the apple down to the earth. Every object with a mass attracts every other object with a mass. He realized that the force of attraction between two massive objects depended on the mass of the object and the distance between the two objects. Some questions to think about before you come to class. If the planets are orbiting the sun, what force is keeping them in orbit? What force keeps the moon in its orbit? And what could the force of gravity be universal? Newton's law of universal gravitation. Any two objects attract each other with a gravitational force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force acts in the direction of the line connecting the centers of the masses. The formula is f of g is equal to g times m1 times m2 divided by r squared, where g is the gravitational constant, and it is 6.67 times 10 to the minus 11 Newton meters squared over kilograms squared. M1 and M2 are the mass of the two bodies, and R is the distance between them. So why doesn't the moon fall straight down into the earth? Law of universal gravitation is an inverse square law. If the distance doubles, the force drops to 1/4 of the original force. If the distance triples, the force drops to 1/9 of the force. If the distance is multiplied by 10, f of g is divided by 100. And you can see that the curve drops pretty quickly down to where there is a very small force between the two objects if the distance is very large. Jimmy is attracted to Betty. Jimmy's mass is 90 kilograms. Betty's mass is 57 kilograms. If Jim is standing 10 meters away from Betty, what is the gravitational force between them? We would use f of g is equal to g m1 m2 divided by r squared. Plugging in the numbers, it turns out that it is 3.42 times 10 to the minus 9 newtons, or a nanonewton. The moon is attracted to the Earth. The mass of the Earth is 6 times 10 to the 24th kilogram. The mass of the moon is 7.4 times 10 to the 22nd kilogram. If the Earth and the moon are 345,000 kilometers apart, what is the gravitational force between them? Plugging in the numbers, you end up with 2.49 times 10 to the 20th newtons. Homework is simply to review Chapter 7 practice problems, and study for the chapter test.